recording. How much of the Spanish do I understand? I can read basically everything in Spanish. I always say that, and then somebody who grew up in Mexico starts talking to me in Spanish, and I understand, I think, what they're saying, and then I say something back, and they look at me very weird. Do you speak Spanish? Yeah. Grew up native? Spanish. Okay, yeah. We're trying to raise our kid. My wife's trying to do bilingual Spanish and English. I'm trying to do trilingual with throwing in Korean as well. Everything I did over there was in English, so didn't need to know Korean. I still don't really know Korean, but I'm trying to learn it, and teaching my kid Korean's excuse to learn it, sort of. But that's the main reason that, yeah, trying to get good at that is to interact with the North Koreans better. Okay. Today in class, last Friday, let's pull up our class. We went over the SQL quiz stuff that you'll be having a quiz on Wednesday. Again, the practice problems were in this quiz practice.sql file. The create tables.sql file is something that I will provide another copy of during the quiz time for you, but then there'll just be 4 problems similar to the ones in here that you'll have to be able to solve in your head or on paper, but without a computer, and figure out what they're doing. And the quiz, the SQL stuff is super important, so it's worth twice as much as the previous quizzes on the PostgreSQL stuff and Git, so 8 points total. And then we're going to have another quiz on more SQL stuff next week that'll all be cumulative. So you really want to make sure that you have this first SQL stuff down pat in order to do that. And again, all the material from this first SQL quiz is supposed to also be helping you with that Pagilla homework assignment, which is due tomorrow. That is our review for where we're at. There's one last small concept that we need to be able to do for the Pagilla homework assignment. So creating functions, we'll do that as our first thing today. And then there's another quiz practice 2 file here that we'll go over today. Maybe finish, maybe just start. But this will be the notes for your second quiz, and then also prepping for the Pagilla homework 2 assignments. Any questions about anything, where we are, what we're doing? Everyone's on board, on the same page? When is the Twitter assignment due? Not this month, next month sometime, I think like the very beginning of next month. Speaking of which, so if we come over to, I'm logged in the Lambda server over here. If you just type top, there's lots of ways to measure the activity that's going on the Lambda server. This is one of them. You can see that lots of people are maxing out CPU usage on the Lambda server right now. This is a good thing. And it's not calling out Sophia, it's calling out everybody else who hasn't started yet, because as more people are using the Lambda server, you'll notice that the things slow down. Here we go, we can clear that for you. The things on the Lambda server will be slowing down a little bit, and that will mean that the computations for the MapReduce Twitter assignment will take longer to do. And so the longer you wait, the longer it'll take, and the more time pressure you'll be under for like 2 reasons. So definitely recommend getting started on that now and finishing it as soon as possible. Good question. Any other questions? Yes. Once you have all those map things run, then that's vast majority of the processing. Everything else is yeah, everything else is pretty quick. Question?
You said we need at least a week. If everybody's right.
Question is, I said in computation takes at least a week. That when I run it by myself, nobody else is using the Lambda server. Everything will finish within a day. It's actually not the CPU load that will slow things down too much if more people are using it. It's the hard disk load that the data sets store just on what we call the spinning rust hard drives. So not solid state things, but the HDDs. And the more people are using it, the slowdown is actually quadratic. So if there's 10 people using it, expect it to be 100 times slower. But yeah, so I said that if you are finishing the heavy computation stuff with less than a week left, then strong chance you won't finish in time. Good questions. Any other questions about anything? Everyone's ready for the SQL quiz on Wednesday? Heads shaking every direction. Yeah, so yeah, I don't consider myself to really be a databases person. I consider myself to be much more of a machine learning person. So all the stuff on these database quizzes this week and the upcoming weeks, I know them just long enough to be able to like teach them for a month, and then I totally forget everything afterwards and have to relearn it again every year. So that's totally okay if you end up being in the same situation. If you're going to an interview situation in a data science world doing things on SQL, then so the purpose, what those SQL interviews will look like is they'll go one of two ways. Either they will give you some sort of like very toy problem like these quizzes and expect you to work it out in your head what's going on, or they will give you like their actual production database, something similar to Pagilla, and have you write SQL queries against their production database. And really, so the purpose of the quiz combined with the Pagilla is that if you can do these problems, then you are going to ace whatever sort of SQL questions people are going to give you on in an interview scenario. In an interview scenario, let's see. So for the quiz scenario, I'm really going to be like selecting problems that are like pushing all of these weird edge cases on things. In an interview scenario, people will not care if you get the weird edge cases right so much as get the big picture ideas. But just to enforce that you've all seen these weird edge cases at least once in your life, I will be emphasizing all of those weird edge cases on the quizzes. And so expect them to be harder quizzes. Questions? Pagilla homework assignment. Sorry, not Pagilla. Yeah, the Docker Compose Instagram homework assignment. Originally due last Tuesday, then I extended it up until this Sunday, and so as of today, is the 1 day late day. And so it'd be -1 point today, -2 points tomorrow, 4 points, and then 8 points, and then 16 points. And yeah, so this all these Pagilla homework assignments, there will be no extensions for whatever reason. So the homework definitely due tomorrow. Yeah.
I didn't really understand like
Okay, so the question is on the SQL quiz. Let's talk about some stuff. And so here on my terminal, I'm going to go into my SQL quiz folder, project/SQL quiz like this. And let's see, do I have something running? Docker PS. I do have it running still. So Docker Compose exec pg psql like this, and then down here I will open up the actual quiz practice.sql file. And the question was out this count one problem on line 28, how exactly the count one is working compared to something like the count star. Is that right? And the answer is that if you have something like this and something like this, they're always going to give you the same results. Count star here and count one are going to give you the same results. That they're just going to, for each row over here in this table, whatever it is, it's going to substitute this thing in between the count function and then count how many rows there are. Neither of these two things can ever evaluate to null. Neither of these two things here will ever evaluate to null. And so it will count every single row, and these two things will give you the same results. Again, the reason why the pSQL here is taking a minute to start is it's waiting its turn in the operating system for the other processes doing people's Sophia's Twitter assignment to give it a chance. No, don't change anything. All of your permissions on the Lambda server are set so that technically there's what's called a niceness level in Unix. You can use nice to change the priority of processes, and all of your programs are set by default to be maximum nice to other processes. And there's effectively no way that you all can bring down the Lambda server from doing too much stuff. So you should never feel bad about maxing out whatever your permissions are for anything. That's just why launching a new process can take a little bit longer right now, but once something's launched, you should be able to have good interactivity with it and not have to wait for it. But this, yeah, so the specific question here, difference between this and this, it's going to give you the same number in all situations. The thing where these things start getting different is when you're adding like distincts. And if we were doing something like this, adding a distinct over here. Now, anytime you have the distinct keyword, this is true for all aggregate functions, not just for the count function. Although distinct is commonly used for count, it can be combined with any other aggregate function. And what it does is it first takes does this computation right here, this computation right here to the right of distinct. It does it for every single row and then removes duplicates. So every row will be computed to the value of 1, and then it will remove duplicates. So this will come out to just 1 at the end like this. Distinct star is a meaningless thing. You'll get an error message like that. Does that answer your question, Kevin? There you go. Question is, for the Pagilla homework, what are the restrictions? The answer is you can do whatever you want. If you find some sort of solutions online to these things, which I don't think there are, you're welcome to, use whatever you want. The only thing you're not allowed to do is just go to somebody else's GitHub repository and look at it. Yeah, there are lots of SQL things that are useful that we're not going to be covering explicitly in class. We're going to cover all the hard things, what I consider to be the hard things in class here, the things that you're both likely to get confused about and likely to get interviewed on in a SQL interview situation. But if there's other things that you want to use, then feel free to do it. Yeah. Oh, the question is, can you use the between keyword? And the answer is you can use the between keyword, but if you do use the between keyword, you are going to get the wrong answer. Postgres implements the between keyword, something we didn't talk about in class, because it's part of the SQL standard. And Postgres, one of their missions is to be standard compliant as much as possible. It's the most standard compliance of any database. But between does not do what you think it does. It does not really get things between other things in weird edge cases. And so you shouldn't use it. So yeah, I have a note somewhere in the README file saying, don't do this. There's a link to the actual detailed explanation in the Postgres documentation if you're curious about why, but we're not explicitly covering it anywhere because it's not something that you should use. But you are allowed to use it. I just do not encourage you to use it. Good question. Any other questions so far? And so there is, before we actually go on to the SQL quiz 2 stuff for today, there's more for us to talk about the homework. So this is a good time for us to switch over to the actual homework to do ///temp/ Pagilla homework. There we go. And compose up -d. And then there's function syntax that we haven't talked about yet that we'll talk about here as soon as the Lambda server lets me. And then we will we'll move on to the quiz. Is that what your question's about, or something different?
The question is,
I'm going to go ahead and open up another session right here and cd /Pagilla homework. And let's just move you away and make you big and clear your screen here. And now we can, so if we look inside the SQL folder right here, the SQL folder right here, there's three of these problems labeled with the underscore function in their name. And if we take a look at those, so like 02.SQL, vim SQL /02, and I'll do star.sql using our glob here, and then add the -p, open them up both at once. These two problems are closely related to each other. If you just go back and forth, you'll see that the English documentation at the top, basically the same, just a minor difference. And the function version of this problem is intended to be essentially the same code, but you're going to be creating a function that is going to solve the problem instead of so solve the problem in a generic sense rather than just like a one-off solution to the problem. So in this case, it's asking find the actor ID if every actor's first name starts with J. And then up here, this first letter is an input thing to this get actor IDs. And you need a generic piece of SQL code right here that's going to solve that. And if we scroll down a little bit, then there's this is how we call a function from SQL, just sort of the standard function syntax from other languages. Here, this function type, this get actor IDs, we can see up here that it returns a table type up here, returns table. And so wherever we're using this function, it must be at the location where we would be using a table in ordinary syntax, in ordinary SQL. And so here it comes to the right of the from operator, or the from keyword, that this is a full table right here, and we're selecting everything from that table. And so this is a more sort of exhaustive test of your ability to do this kind of thing, because now you have to do it just a little bit generically. And my sense is that at least in this first Pagilla homework, anything that you're able to solve in the non-function version, it'll be really easy to take it over to the function version, but that might be less true for some of the future homework assignments. So we'll go through and solve this real quick, and then and see how the function syntax works. So temp / Pagilla homework, there we go, docker ps, okay, it is running docker compose pg exec psql, and it knows that to connect to the Pagilla homework psql or the Pagilla homework database and not the SQL quiz database, because I'm in the Pagilla homework folder right now. I have both of the databases running, but just whichever folder you're in, that's the one that's going to connect to using that docker compose. I'll go ahead and start up here writing out what I think the answer will be. So find the actor ID of every actor whose first name starts with J. We come back over to our where's the Pagilla homework? I'll just type it in up here. Pagilla homework. We have that picture of the database. We'll be talking more about these pictures later on, but for at this point, what we just care about is that each box again is a table. Each of these strings inside of the box is one of the columns. And so it's one of the actor ID of every actor whose first name starts with J. So it's both in the same table right here. Not going to have to do any joins or anything fancy. And there we go. So we'll try select actor ID from actor ID of every actor whose first name starts with J from actor where first name like J%. Maybe I'll do an I like just to, again, the I is case insensitive, like is case sensitive without the I. The percent here corresponds to like a glob type character. So this is the J must be the very first letter, but then we don't care what comes afterwards. And if those are the right names from the columns, then I think that will probably work. Let's just check actor ID, first name, actor table. Yep, those are the right names of everything. Oh man, and it looks like I typed in my command wrong down here. No such command, PG. Oh, I got PG and exec backwards. Up here, colon, WQA. So while that's waiting, I'll just retype it up here. Docker compose exec PG pSQL. And hopefully I think that's correct. Potentially running through all of these things in real time with you rather than having it all set up, just so that you can, you'll have to be running through these things when you're working on problems, just so you can get a sense of how I deal with all these kinds of issues that come up, like various slowdowns on the server or other problems. So down here, the first command I typed, Docker compose, I got my PG and my exec backwards. I did the name of the service before the command to pass to Docker compose, and so it was giving me an error message. Fix that up here, put them in the right order. And I'm gonna, I like having Vim on top, so I'll reopen my O2 star.sql-p right here, and with my magic hotkeys, move that one to the top. And we wanted to check to see, is this going to work? While this is still loading down here, in order to, once I check that this is in fact correct, I'm going to have to copy and paste my solution between these two tabs right here. In Vim, again, yanking is the Vim word for copying. YY yanks the current line that your cursor's on. So my cursor's currently on line 6. I just press YY, yank that line, GT, come over to the function, 7GG, take me to line 7, P to paste that. I'll go up arrow DD to delete that line. And now I have my SQL code inside of this function call right here. Here, so select statements always return tables as their output. So it's returning table, that's good. Here, the part that's different is that this J now needs to not be hard-coded, but needs to come from this text variable right here. I'm going to replace this J right here with the this variable right here. I'll press FJ like this to move my cursor way over there. And the way to get access to this variable inside of one of these function calls is $1 will give me the first variable that the user input in their thing over here. This is going to be text, a string object. The way you concatenate strings is the double vertical bars, and that $1 will take the place of the J. I'll still need the glob character afterward like that. Escape :W, save that. And my guess is that this is a correct solution, assuming I didn't have any errors on the 02, but we'll go ahead and go over there, run it, copy that right here and paste it. There's all of the actor IDs. Actually, I don't think I have an explicit order right here. One of the very common mistakes on these Pagillo assignments is that things will work on the Lambda server, but they will not work on the GitHub Actions. And that's always going to be due to your ordering. If ever you have a situation, if there's ever a situation where it passes on the Lambda server, but not on GitHub Actions, that's due to the order by clause. Technically, without the order by clause, We call the order non-determinate. It means that Postgres is free to choose whichever order it thinks is convenient computationally to use. And so here, this happens to be sorted from low to high right here. Because, and that's what we want, but it's not guaranteed to be sorted from low to high. And if the Postgres server on GitHub Actions is allowed to sort it in whatever order it wants, if the computational environment is there to be conducive to a different sorting order, then it will do so. And so we do want to have an explicit order by clause here, order by actor ID, and we want ascending for low to high like this. So I think this is a better solution to that problem. Paste that right there, and now that's good. And then GT over here, I'd want to also add the order by actor underscore ID, ascending like this, and save that. I'm going to go ahead and set no number here, so I can copy and paste this function right here down into the interactive environment. This is the standard way that I am always debugging things, testing things, whether it's functions I'm writing or actual individual queries. And so here you can see the output for creating the function is just create function like this. And then to actually test it, we'll need to do something like select get actor IDs, and then J like that. And this looks like the same output that I was getting before. Any questions on? So yeah, again, the key thing here about using the function, what's different is just this $1 will get you whatever the parameter is that's being passed in right here. I think all of these functions just have a single parameter, so it'll be $1 to get that. And then there's many more test cases now since there's functions to test against. Yes.
So if the question is with the explicit order, but it's failing with the actions,
question is, if the question does not specify an explicit order, and it's, I think, common for the questions not to specify an explicit order, then what do you do? The answer is that you have to create the figure out what the order is yourself and add an order by clause. Every one of these problems will need to have an order by clause so that the results are in a deterministic order. Without the order by clause, Postgres is free to rearrange things however it wants, and so you need to have an order by clause. Again, it's very common on these sorts of problems in the real world. You have a non-technical person writing the statement that they want of what they want the SQL query to do, and they're not going to be thinking about details like ordering very often, but you'll have to sort of fill in those gaps as needed. So it's intentional that there are things that you're required to do for these problems that are not specified in the problem statement. Good question. Kevin, you had a question on?
Yeah, it was a question about using, like, I guess you can't use aggregate functions for clause, and I think it was supposed to like exclude certain counting work.
Yeah, so anytime you're tempted to use aggregate functions in a where clause, if you're tempted to use aggregate functions in a where clause, you probably are intending, or you probably should use instead, use a having clause. That the having clause in the where clause, very similar. But again, the where clause happens before group by, having happens after group by, and after the aggregates occur. So you can use aggregate functions in the having clause. And I think it's probably this one, but at least one of the solution, at least one of the problems in here, I did use a having clause in my solution. that answer your question? Any other questions? Yes.
There were two variables we can just do.
Yeah, so for functions, if you have multiple input variables, yes, you can just do $2 for the second one. It's also possible to like name these variables and do like $name to get access to them. You will, I mean, this should be somewhat reminiscent of like the bash POSIX syntax for variables. That this again, SQL was created in the 70s. At the time, people didn't know how to write compilers or interpreters or programming languages that allowed you to just name your variables whatever you wanted. So you always had to, every programming language back then had a $sign in front of the variable names when you're using it. So that's why we have that sort of archaic syntax now.
And then also,
Question is, what if variables are different types? Then what do you do? And the answer is you have to, it depends on the type. That if you were trying to, so if we have like an integer and a string, the integer will automatically get converted to the text type to do the concatenation like this. In general, if you want to explicitly typecast something, then you can do something like this, the colon, and then the name of a type will convert whatever the thing is on the left to the type specified on the right. This syntax right here is supposed to be evocative of mathematical notation where people will use colons to specify the type of things. But this is the standard way to cast from one type to another in SQL. I don't think I do that for any problems in any of the Pagilla homework things though. But good question. Okay, let's move on to the quiz then. And again, the material for Wednesday's quiz, we've already fully covered that. That is the stuff that is in, so here in the SQL quiz repository, that's the quiz practice.sql file right here. And we're moving on to this quiz practice 2.sql file, which is the printout for today. And well, that's what we're going to talk about. Coming over here, let's quit out of all these things. CD question. Yeah, we'll do that in the SQL folder. Dash. So here, the super common terminal shortcut that I use all the time is CD dash. Takes you to whatever CD, whatever folder, whatever your previous working directory was. So in order to be able to use things like this to switch around between projects efficiently, you'll see me commonly doing, so like my previous CD command looked something like this, moderately arcane path right here. But by combining this all into one CD command, it let me easily go back and forth between my two projects like this. Reducing the number of CD commands that you use is a good practice because it just cleans up your bash history, makes it easy to stay organized and travel to where you want to go. So down here, we'll try CD dash. That one took me back to my home folder, project/SQL quiz. There we go. And let's reset both of these two things, reset both that thing up there, and rerun my exec SQL. There we go. It's the right order right there. And I want to get rid of that menu bar. Up here, I have a quiz practice 2.sql file. In your own SQL quiz folder, if you just run the git pull origin master, that should update your file, your repository to be up to date with the one on GitHub and get you access to this version 2 one right here that we'll go over here in a minute. The question was that Nico asked was, if we look at quiz practice.sql and then the group by and how group by interacts with aggregate functions, you always do the grouping by operation first and then any aggregates over here. So first we Yeah. As soon as P-SQL opens up here, we'll break this down step by step, but we first will group by the leftmost column over here. And then for each of those different values, we'll run this count star. So up here, again, in order to copy paste, set no number, copy that down here. That's the final result. Anytime you have a group by on the quiz, you're likely to have 2 columns in your output. You'll have to provide the entirety of the table in order to get full credit. And the fruit A column over here is all the different fruits in our fruit A table. And then the count stars, their corresponding counts. In order to break this down step by step, when you have a group by, you can delete the group by and delete any corresponding count in your column list up here. So I'm going to press the up arrow. And in this P-SQL environment, you'll notice that my cursor can go multiple lines. The up arrow will not take you to the previous lines. You'll have to use the left and the right arrows. I'm holding down the control key to jump one word at a time instead of one letter at a time. And I'm just going to delete this group by clause and then delete this count star right here so that it's like that. And again, this is the process to understand what group by is doing. Just delete the group by line, delete any aggregate functions. And here's what we have. And now in order to interpret the group by, in order to predict what it's going to do, we'll have one row for each unique row down in the results over here. We have these 2 rows are duplicates. They're both null values right here. So we'll have a null row and we'll run count star on this entire subset right here. There's only 2 of these rows. So we have a 2 next to the null, only 1 orange, only 1 cucumber, only 1 banana, but then 2 apples right here. And so we'll have a 2 next to apple, a 1 next to all 3 of these things. Press the up arrow again. And that's what we did in fact get. 2 apples, 2 nulls, everything else is 1. Did that answer your question? Okay, the main thing about, where we left off on this first quiz, if I press Shift G, take me down to the bottom, we were talking about the different types of joins. And in particular, we spent a lot of time talking about the cross join, which is like the cross product. You should be thinking about the cross product of every possible combination of every row with every other row. And then we talked about one type of join, which is the inner join. The inner join over here, which is you can write out inner join or just join by itself in the SQL command. It's common to just use join by itself to specify an inner join. And an inner join is just a cross join that that has a condition on it that we're filtering the rows for. So up here, any of these where clauses, here's a very complicated, relatively complicated where clause, but that could be rewritten as an inner join, rewrite the cross join as an inner join with this expression, the where clause expression, inside of the on expression over here. So join is syntactic sugar over the cross join. This second quiz is going to, what we're building up to is introducing left and right joins, outer joins. And in order to do that, we have to introduce a lot more SQL syntax. So the very top of this is we're going away from joins for a little bit. We're going to talk about things called subqueries and set operations. But then by the bottom of this document, we'll be getting back to joins. We just need these other tools in order to talk about the left and the right joins. Again, in Vim up here on the top, I've just opened up the practice quiz 2 file, and that's what we're going to start with. Any questions on the setup, where we're at right now? Okay, my recommended way of following on, taking notes with this is to make annotations on the printout so that you'll have them available for your actual quiz, and then whether you choose to also run these statements right now or later is up to you. But we would definitely recommend that you run all these before the quiz and understand why they're getting the output that they are getting. In order to be able to copy and paste things from the top down here to the bottom, I'll again do the :set no number up here. And now we can just copy and paste straight from here down to here. The first new technique that we have is this idea of a subquery. And in a subquery, or what is a subquery, is that when you have a select statement inside of another select statement somehow. A select statement will always return back a table as its results. So you can see here, for example, the output of the select statement from that we were just talking about gave us this two-dimensional, two-column table right here. And so the select statement can be used anywhere where a table would also be allowed to be used. So far, the only place that we really know of where a table can be used is to the right of a from statement. And so here we'll put this, this select statement inside of this other select statement. Here, this inner select statement, we run that. You get this table right here, has 7 rows inside of it. And then the outer select statement is just counting how many rows there are in this inner select statement. So we get 7 as the results. This particular combination of select statements is not doing anything interesting at this point, that this could be 100% equivalently rewritten as select count star from basket A. It's the same exact thing. Anytime we're using a subquery inside where in a location to the right of the from clause, we must specify a name for this subquery table inside of Postgres. Again, this is part of the SQL standard that you have to specify the name, and so Postgres requires you to specify the name, even if it's not exactly ambiguous. Very common practice in the Postgres world just to name your subqueries as T, the letter T, short for table, and if you have multiple of them, then it'd be like T1, T2, T3. This as keyword right here is optional, and so it's most often you will see it written without that, and it just means that this whole subquery, its name is the letter T right here, but that's syntactically perfectly okay. Really, the motivation for having subqueries, though, is that we'll be able to combine them with our other operations here in a minute. So let's just jump down here to our first new interesting operation is what we call set operations in SQL. The joins that we've been talking about so far, they sort of combine tables horizontally together by like matching 2 rows together and expanding the number of columns. The set operations, though, will combine tables vertically and add to the number of rows. Here's our first example of a set operation right here, this union all. It's sort of the simplest one. And again, anytime on one of these problems that we want to understand what's going on in the set operation or in this inner subquery, we can just copy and paste the inner subquery down here and run that by itself. The purpose of the subquery here is just so that we can use the count star on it, so that for the quiz itself, you'll only be writing a number, and you won't have to write out the entire table. What the union all operation is going to do is it just concatenates the results of these 2 select statements, takes the output of this and puts it at the top, and then takes this and puts it at the bottom. Hit enter. You can see here's apple, apple, orange, banana, cucumber, everything from the top, and then everything from basket B below. On Vim up here in the top window, I'm going to go Tab E, open up the create tables environment, and you can see that what we're inserting into basket A, 2 apples, 1 orange, 1 banana, 1 cucumber, and 2 nulls. That's those right there. And then going on to everything in basket B, 2 apples, 2 oranges, and so on. The couple of subtleties about the union all operation is that there is no removal of duplicates going on. Personally, I found that this is almost always what I want to do when I'm concatenating like the output of two results is that I want union all, but the vast majority of tutorials or explanations never even mention union all, and they instead just mention union keyword by itself. If I press the up arrow and then go over delete all, what's going to happen is that now it's the same thing. It first concatenated the results of the two queries, but then it also removed any duplicate entries. And this means duplicate entries, whether they appear in both tables or if they're duplicates just in a single one of the tables. So now we only have a single apple, a single orange, a single null value, even though when I had the union all, I had 4 apples and there's going to be 4 null values and 3 oranges inside of here. Very easy to get these two different things confused on the quiz. The difference between union and all, it's just straight up concatenation, but union is like the actual set operation that removes duplicates. Any questions so far about those? Question?
Sorry, yeah. Do your columns have to do this? Or union all, or is
Yeah, so the question is here that we have a fruit A and a fruit B, and what exactly are the requirements on our columns in order to be able to union all together? And for the purposes of the quiz, you don't need to know these requirements because everything that I'm going to give you is going to be syntactically valid. But for the purposes of the homework assignment, where you're writing your different queries, it will be useful to know exactly what the requirements are. The requirement is just that the types of the columns match each other. So here, the fruit A and the fruit B. If we come back over to our create tables, fruit A and fruit B, they're both this varchar 100, so they have the same type. So they match each other, so we're allowed to run this. If I press the up arrow, rerun this query, you'll notice that the name of the table is fruit A, that the name of the column is fruit A. The name of the column is just going to be whatever the name of the column is on the first select statement, and it's going to ignore the name of the column on the second select statement down here. If I were to change this, I'm in the pager environment down here in pSQL. It's called the pager environment. It's like a read-only version of Vim. Press Q to get out of that. If I press the up arrow here and modify this query down here, I'm down here inside of pSQL modifying this query. I'm going to add ID comma down here. ID comma. This bottom one has 2 columns down here. This top one up here has only a single column. This is not going to match types because 2 against 1, and so we're going to get an error message down here saying that the union query must have the same number of columns. If I press the up arrow again and also add the ID column to the top query, then this will be okay. That this ID is going to refer to the ID from basket A, this ID will refer to the ID from basket B, and now we have an integer and a text thing. Hit enter, and everything will be okay with that. You'll notice that if I use the union command like this, union shift G takes me to the bottom, has 12 rows. When I use both columns, ID and fruit, press up arrow, remove the ID column, only has 7 rows with a fewer number of columns. So because union removes duplicates, changing the columns can change the number of results that you get. But because union all does not remove duplicates, changing the columns will never change the number of results that you get. So I'll write that out. Union removes duplicates. So changing the columns can change the number of rows. Union all, changing the columns will never change the number of rows. I forgot what your question was, Sophia, but did that answer it somewhere? Yes. Can you say that again?
If you just try to union all fruit A on the top and then just ID from basket B. So like the 2 columns.
So types don't match. Yes. I did the number of columns not matching before. Now we're going to do the types not matching. Here's text up here. Here's integer down here. And you'll see that it can't character varying and integer cannot be matched. The error messages here in Postgres and all databases are notoriously bad. That if you didn't already know what this error message was saying, it'd be really hard to figure out what this is meaning. But it's because these two types are different. This one up here, the character varying, and this one down here, the integer. Good question. Any other questions so far? Okay, there's 4 set operations that you need to know for the next SQL quiz. Union, union all, I think those are the easiest ones. Actually, yeah, maybe before we get on to the other set operations, you'll see that the where clause attaches to the select statement here. The where clause attaches to the select statement like this. And when we have a where clause down here that's after this last select statement, it only applies to this select statement and does not apply to the one up here. Let's go past the unions. There we go. The next one, intersect all. This is just your standard set intersection. This one is always confusing to me about exactly what the exactly what this all version does. Like the intersect, I don't know, set intersection makes sense to me. This one I always make mistakes with. So maybe you're like me and will make mistakes with this. And I will probably have something, or I will be designing the quiz to be something that would be hard for me. So there might be things that like this that would be hard for me on the quiz. So this returns all rows that are all rows that are in both queries. There we go. Returns all rows that are in both queries. So what exactly does that mean? We have select fruit A from basket A like this. So we have apple, apple, orange, banana, cucumber over here. Notice that we only have one orange up here in the fruit A, only one orange in basket A, but in basket B, we have two oranges down here. This is the part that's always confusing to me. When we intersect basket A and basket B like this, oops, and that's the intersection without duplicate removal. When we intersect with duplicate removal, because there's only one orange in this first basket A up here, we're only getting one orange in the second one down here, even though there's two oranges inside of basket B. If we reverse that, change this to basket B, fruit A like this, still the same. Only one orange down here, even though there are two oranges inside of the basket B. Two oranges inside of the basket B, but no matter what the order is right here, still only getting one orange down here in my fruit B results, no matter which order I do the intersection in. The intersect all doesn't have that problem because no matter what, you're getting duplicates or you're removing the duplicates, so you don't have to worry about trying to count the duplicates correctly. The intersection is not a super interesting of the set operations. I've never actually had an occasion to use it in practice, but it is there. There we go, over here. It's the implementation of what's called the except one is based on intersection. So that's the main reason why people care about intersection. But except this is going to be useful when we're defining the left and right joins later on. So this is one that you there will definitely be multiple quiz problems involving except, because there will be quiz problems involving the left and right joins, and those internally use this except operation. So this returns all rows that are in the first query, but not in the second query. And started that off with except. The except all is the one that we should start with here, run that. And so banana and cucumber are the only rows in the first query. Up here in create tables, we have apple, orange, both of these are in the both baskets, apple, orange, apple, orange. So that one is not getting passed on. The orange and banana, sorry, orange and cucumber, banana and cucumber, this one and this one right here. Banana and cucumber, they're in basket A, not in basket B down here. And then the nulls up here, nulls are in basket A, not in basket B, so they're not getting passed on. In this case, there's no duplicates of those, so accept and accept all are the exact same results. Yeah, the best way to get a sense of these is just to make predictions about what you think some of these problems are going to do, and then run those problems and see if your predictions were right. Any questions about these set operations? Everybody just wants to take a nap right now. Question?
So if you have like 2 oranges in one basket A, then 3 in basket B, you did intersect all and you get 2 back, but if you didn't intersect, you get 1 back.
So here, your question is that, so here we did intersect all from basket A to basket B. And the question, I think, is if we were to reverse these, what's going to happen? And the important part about this is that in the basket B up here, we have 2 oranges down here, but there's only 1 orange up here. And so that 1 orange down here is left over, and and so it's included in the accept.
Okay, I meant for intersect.
Not intercept, intersect. I don't know how to spell. SECT. Yeah, there's still the apple appears down here twice because there's 2 apples in both of them. The orange appears down here once, no matter which order you do it in, because there's only 1 orange in the basket A. Only 1 orange in the basket A up here, but there's 2 oranges in the basket B down here. But no matter which order you put it in, only one of these oranges can match with one of these oranges, and so you only get 1.
And if you just do intersect, it'll only return 1 at most.
So for all of these operations with all of these SEP operations, the way to understand it, the way that they're actually implemented is that it first does the, so like for intersect, it always will first do intersect all and then remove duplicates. So if you understand intersect all, just do that, what it's going to get, and then remove the duplicates, then you'll get the right thing for intersect. I don't know if that answered your question though. Okay. Yes.
So would intersect have the same effect as a or like selecting for or selecting fruit A from basket A and joining basket B on like fruit A?
Question is, can you implement the intersect in terms of a join somehow? So
I mean, the idea I have is that when you like join and you like are matching like fruit A is with fruit B, and you're joining these 2 tables, then it would do the same thing. That's basically like matches when they have like the same. So
you're suggesting something like that?
well, I was saying fruit A was
Fruit A, yeah. So the okay, yeah, this is a good point about the difference here. So first of all, if we have the duplicates here, but more importantly here, when we have the equality over here, the equality here is remember that anything equals null is always going to evaluate to null. Any operator null will evaluate to null. And so if either of these two things is null, then this won't work. So in the inner join, this is what I've done here. I've used the cross join syntax, but this is an inner join, and the inner join is basically ignoring nulls. So you'd have to do more things to account for the null as well. Okay, move on from the set operations to the in operation. This one, at least at first, is very intuitive, and I don't think people will have problems with this on the quiz. That the in operation is to the right of it, you have a table. I put list up here in quotation marks. Technically, it's there are no lists in SQL. This is a special type of one column table created with these parentheses right here. And this is syntactic sugar for, so A in A comma B comma C is syntactic sugar for A equals A or A equals B or A equals C. The in goes through starting from the left, going to the right, just checking for equality, and then combining with them with the or operation. So the main reason to know this desugaring is so that when you get to the null values, to understand how to interpret the null values, you'll be able to use your knowledge from the equals operator with null values to know that fruit A in null will, even though we have null values over here, nothing is ever going to be equal to a null value. And so this right here, select count star, we'll remove the count here for a second so we see the actual results. We get 3 and 4 where the ID is actually equal to 3 and 4, but up arrow, change this to null. So I'm running this one down here right now. Hit enter. We'll never have results down here. Whenever you have in null, this will never give you any results back because it's doing equality with null, and it doesn't make sense to do equality with null. So that's really the only tricky part about the in keyword. Otherwise, it does exactly what you expect. The not in like this just propagates the not equals in front of each of these, or the not operator in front. These two things exactly the same up here, and they just do exactly what you expect they would do. So we'll run that one here. You get everything besides the 3 and the 4. Take out the star like that. So we get everything besides the 3 and the 4. Again, maybe the confusing part here is that it's not giving us the equals because, or it's not giving us the null values because nulls are not equal to nulls as well. So no matter what, you'll never get the null values from a query like this. The interesting use of the in keyword is when we have subqueries to the right of the in keyword. So now we've seen we're going to see two possible locations where we can have subqueries. We can have them to the right of the from keyword right here, where we would have an ordinary table name like this. We could replace basket A with a subquery, or we can replace this part over here with a subquery. So here's a very simple subquery, this select 3 union select 4. The select statements without from clauses. This right here just gives me the 3 and the 4. I've seen this before a little bit. Just select 3 gives you the number 3. Union that with select 4, so 3 and 4. So this table right here just simplifies to that table right there. They're the exact same thing. Just this is written in a longer notation right here. Those two things are the same thing. That thing right here, apple and orange, that's the same thing as this right here. These are the same thing. But really when they start getting more interesting is when, rather than hard coding the values, you have an actual table that you're selecting from. and then the list that we search through. So if we have select fruit B from basket B like this, now we have apple, orange, watermelon, pear, null, all of these values right here. And we're doing the in keyword. So we'll select all of the things from basket A, where fruit A is one of the entries in basket A. So everything where fruit A is apple or orange or watermelon or pear. I'll take this full line right here, run it, delete the count so that we can see the actual results right here, run it, and we get apple and orange, apple and orange. These are the only two columns, the only two rows, apple and orange, that correspond to having a corresponding row in basket B. These two right here, apple and orange, but banana and cucumber not over here, so those are not getting included. At least I think semantically, most students find this not to be too bad. Going through the actual process of running the first query, getting the table, and then running the second query based on that, possible to make mistakes there. But at least the semantics is, I think, relatively straightforward. Are there any questions about the in combined with the, yes?
The table, counting from has the fruit twice. Like it was fruit B instead of that. It was like from basket B or fruit B, fruit A.
So select fruit B, then what?
Backward, basically.
So you're saying the over here is the A's and over here is the B's?
Yeah.
So this is the subquery right here. We have apple, orange, banana, cucumber, null. And then we're wanting to select star from basket B where fruit B in that whole thing. Then the oranges will appear twice. Yeah, so the in over here, it just, whether it's in it at all, whether it's in it once or twice, doesn't matter. This is happening on just like an individual row by row basis, not thinking about more rows at a time. So you get two oranges here and not just one. Whereas the reverse, you get one and not two. Anytime you have a subquery like this over here to the right, if we were to add the distinct keyword, so here, right here, this is my subquery that is to the right over here, hit enter, you can see that we have duplicates. If we were to remove the duplicates by adding the distinct keyword inside of the subquery, that will always give you the same answer. So change this over here, select distinct. Adding the distinct keyword into the subquery will never change your results. Adding the distinct keyword into the subquery that's to the right of an in to the right of an in clause will never change the results. Okay, the last big topic, the biggest topic, the one that everything else is related to, is how these left and right joins work. And so again, we've already seen the inner joins. This right here is a syntactic sugar over the cross join A comma B, where we have this condition. The syntactic sugar for a left and right join is significantly more complicated. So here, this is the syntax that people type in their Postgres or whatever they're doing on SQL. And this is the resulting equivalent syntactic sugar that you first have an inner join, and then we will union all. So combine everything from the inner join. It's everything in the inner join plus some other stuff. Everything in the inner join plus this stuff down here. And this is going to use the except all clause. This is the most formal, most correct thing to do. But before we go over exactly what this is and try to understand it, there's a simpler version down here for whenever our condition has an equality right here. And this is the condition that 99% of the time you'll want to use in practice. That you'll, again, it's the inner join up here, then a union all, so not removing duplicates from a subquery, this select right here, and a not in clause right here. We're going to come down here. Anytime you have one of these left joins and you want to understand exactly what it's doing, the way to understand it is to break it down into the appropriate syntactic sugar, starting from the easy one to understand, the bottom one. But if this one's not applicable, then using this more complicated one right here. The way to know whether the bottom one is applicable or not is because we're using an equality condition. If you're using an equality condition, then the bottom syntax is going to be applicable. Here we're using the using keyword. And again, the using keyword is syntactic sugar for inequality. So we're going to break this down one step at a time, undoing all of the syntactic sugar until we get to a point where it is just clauses that we know how to use, and then we'll run them one at a time. And I don't think we actually have time left to finish this problem right here and get the final results. So this will be a good spot for us to stop today. Starting in class on Wednesday after the quiz, we'll go through breaking down this syntactic sugar and seeing how the left and the right joins work. Yeah, if anybody has questions about the things that we covered today or things to expect from the quiz or any of the homework assignments, happy to stick around and answer them. I also have the office hours right after here to answer questions out as well. That is it for today.